Question number 4. Suppose you're told the functions f of x and g of x have graphs that are images of each other by the reflection across the x-axis. Then what we would know is that the opposite of f of x is equal to g of x. In other words, what we see for f of x, if we reflect over the x-axis, we are taking the opposite of every f of x value, and it's your g of x value. So in part A, when it talks about what relationship would you expect between the local maximum and minimum points of the two functions, well, whatever we have for a maximum point for f of x, we would expect to have minimums for g of x, because if we are going up a units, then in g of x we're going to be going down a units. And what relationship would you expect between the zeros? Let me finish. For minimum points, then, whatever we have for a minimum in f of x, we would have as a maximum in g of x. The relationship between the zeros, when we look at zeros, by definition, f of some x value is equal to 0. And if we take the opposite of f of x, well, the opposite of 0 is still 0. And we know that the opposite of f of x is g of x, equaling 0. So the zeros, or x-intercepts, do not change in a reflection over the x-axis. So now in part C, what relationship would you expect between the y-intercepts of the two functions? Well, the y-intercept for f of x is going to be equal to a negative y-intercept in g of x, because if f of 0 is equal to b, so if f of 0 equals b, then g of 0 equals the opposite of f of 0 by definition, which is then equal by substitution b. So g of 0 is equal to the opposite of b. So the coordinates up here are 0, opposite of b. What I'd like you to do now is complete D and E by sketching a graph of f of x, reflecting it over the x-axis, and sketching a graph then of g of x, and writing the rule for g of x.